Hello friends, in this video I'd like to solve the following problem from the Italian Mathematical Olympiad 2008, problem number 4. We wish to find all positive integers a, b, and c such that a squared plus 2 to the power b plus 1 equals 3 to the power of c. So my hints for this Diophantine equation are the following. First, consider reduction modulo 4 to show that c must be even. Then put a on the right hand side and factorize it. Once you do it, you should get two factors and think about, can both of them be at the same time divisible by 4. From there you should be able to find a simpler equation without variable a, and finally reduce this simpler equation modulo 4 again. So two reductions modulo 4 will be going on. So give this problem a try and I will see you in a minute. Okay, so my solution, as I said, let's start with reduction modulo 4. Reduction modulo 4. What do we get? Well, notice that we are dealing with positive integers, so b plus 1 is greater than or equal to, so 2 to the power b plus 1 is congruent to 0, modulo 4. So a squared must be congruent to 3 to the power of c, but 3 is congruent to minus 1. And now let's take a look at possible values of the left and right hand side. Well, a squared, let's notice that 0 squared is congruent to 0, and both plus or minus 1 squared are congruent to 1, modulo 4, while minus 1 to the power of c is congruent either to 1 or minus 1, namely to 1 if c is even, to minus 1 if c is odd. And now we see that for both sides to be congruent, we have only one option, namely here we have to take 1 and here as well. And that means in particular that 2 divides c. Okay, so now we know something. And now let's take again our equation and let's write it in the following way. 2 to the power b plus 1 equals 3 to the power of c. I will write it in this special way, 3 to the power c over 2 squared minus a squared. And then now we can do an obvious factorization, namely 3 to the power c over 2 minus a, 3 to the power c over 2 plus a. Okay, very well. And now think about it. Can both of these factors be divisible by 4 at the same time? Can both 3 to the power c over 2 minus a and 3 to the power c over 2 plus a be divisible by 4 at the same time? No, they can't. No, why not? Because if 4 divides 3 to the power c over 2 minus a, and if at the same time 4 divides 3 to the power c over 2 plus a, after adding these equations together, we will deduce that 4 divides 2 times 3 to the power c over 2, which is obviously not true, because on the right hand side we have only a factor of 2. Contradiction. Okay. So, you know what, let's copy this factorization. Okay. And now let's also notice the following, namely This number is obviously less than this number. Why? Because we are dealing with positive integers. So we have now only two options. We have only two options. Either the first factor is 1 and the second factor is 2 to the power b plus 1. That's one possibility. Or the other possibility, that one factor is equal 2 and the other equals 2 to the power of b. Okay, very well, very well. There is no other possibility, because if the first factor would be 4 or higher, then we'll have the contradiction which was just described. Okay, can the first equation happen? No, it can't. Why not? Because after adding these equations together, we will get 2 times 3 to the power c over 2 equals 2 to the power b plus 1 plus 1. Even number, odd number. Cannot happen. Contradiction. Okay, so we are left with only one possibility with this system of equations. And now let's do the following. Let's deduce a from this system, namely a equals 3 to the power c over 2 minus 2. Yes. And let's put this a into the second equation, and we will get the following. 2 times 3 to the power c over 2 minus 2 equals 2 to the power of b. After dividing both sides, we get the following. 3 to the power c over 2 equals 2 to the power b minus 1 plus 1. If I am not mistaken. I am not. Okay, very well. And now let's consider, because now I want to do another reduction modulo 4, but first I will consider two cases. Case number one. What happens when b equals or 1? What happens if b equals 1? Well, if b equals 1, then we have the following. 3 to the power c over 2 equals 1 plus 1, 2. Clearly contradiction. Nothing special. Let's consider second case. When b equals 2. Then we have the following. 3 to the power c over 2 equals 2 plus 1 equals 3. And now we have some solutions. Namely, c equals 2. And remember that a was 3 to the power c over 2 minus 2. So a equals 3 minus 2, 1. So now we already have one triple of solutions. ABC equals 1, 2, 3. It's one triple of solutions. We shall see if there are more. Case number 3. The general case, b is greater than or equal to. Once again, let's take, let's take this equation, which I mark asterisk, and let's reduce it modulo 4. Reduction modulo 4 of condition, which I marked asterisk. Let's see. Since b is greater than or equal 3, sorry, my bad, there was a typo. Since b is greater than or equal 3, 2 to the power b minus 1 is divisible by 4, so we get, and 3 is congruent to minus 1. So minus 1 to the power c over 2 is congruent to 1 modulo 4. And, well, that can only happen if 2 divides c over 2. So in other words, c is divisible by 4, i.e. 4 divides c. Okay, now we know something new. And now let's take again our equation asterisk. Asterisk becomes the following. 3 to the power c over 4 squared minus 1 equals 2 to the power b minus 1. Once again, we can do a nice factorization on the left-hand side. 3 to the power c over 4 minus 1, 3 to the power c over 4 plus 1 equals 2 to the power b minus 1. Very well. And now you may have some kind of déjà vu because we will be doing a very similar thing. Question is, can both of the parentheses be divisible by 4? So can both 3 to the power c over 2 minus 1 and 3 to the power c over 4 plus 1 be divisible by 4 at the same time? No, why not? Because these numbers are 2 units distant from each other. No, because 3 to the power c over 4 plus 1 minus 3 to the power c over 4 minus 1 equals 2, and 4 does not divide 2. So we have only 2 possibilities. Once again, take notice that this parenthesis is less than this parenthesis, so we have only the following 2 options. Either 3 to the power c over 4 minus 1 equals 1, and the second factor equals 2 to the power b minus 1, or the second possibility, the first factor is 2, and the second one is 2 to the power b minus 2. Okay. Can the first option happen? No, it can't. Why not? Because after subtracting these 2 equations, we will get 2 equals 2 to the power b minus 1 minus 1. And remember that b is by assumption, we are in the third case, b is greater than or equal 3, so this cannot happen. Contradiction. So we have only one possibility, this one, and it's pretty easy to solve this system of equations. Or let's notice that the first equation says that 3 to the power c over 4 equals 3, and that means that 3 equals 4, c equals 4, and plugging it in the second equation, we get 2 equals 2 to the power b minus 2, which means that b equals what exactly? Am I right? No, sorry, my bad. Here should be 4, because 3 plus 1 is 4. So b equals 4 as well. And what is a? Well, let's go back. A was 3 to the power c over 2 minus 2. minus 2, which means that it is 3 to the power of 2, which is 9. 9 minus 2 is 7. And that is another triple of solutions. 7, 4, 4. And there are no other possibilities. So let's write our final answer. The solutions are A, B, C is either 1, 2, 3 or 7, 4, 4. And that closes our problem. So as you can see, a fairly typical Diophantine equation, various reductions, modulo something, and factorizations, and thinking about can both factors be divisible by something. These type of problems appear quite often at various mathematical contests, competitions, and Olympiads. Thank you for watching. I hope that you learned something new this time, and I will see you next time. Goodbye.